Hi, Jen. So we're just going to keep on talking about the double and half angles. So since sine of 60 degrees is equal to the sine of 30 plus the sine of 30, you can use the formula for the sine of the sum of two angles, which is what we just learned before. So we know that the sine of 30 plus 30 is sine 30 cosine 30 plus cosine 30 sine 30. So that's kind of where they got, that's like, you know, I'm not going to go through every single one of them, but that's in essence where they got these equations from. So you can see that the sine of 60 degrees, or the sine of a double angle, is 2 times the sine of 30 times the sine or the cosine of 30. Or in more general terms, sine of 2a is equal to 2 times the sine of a cosine of a. Alright? So these are all of your double angle formulas, double angle, double angle, double angle, and they're all on your reference sheet, which is awesome because you do not have to memorize these, which is fantastic. You only have to plug them in and do the math. These are the functions of the half angle. A little bit more annoying just because they're under a radical, but in essence they're pretty much the same thing. Okay. The expression secant of x, what is going on? Oops. Sorry, my computer just freaked out. Okay, the expression secant of x times the sine of 2x, which is a double angle, is equivalent to what? So you should see double angle, double angle, double angle. That thing should just jump right off of the page at you. So let's figure out what they're asking us. I don't know what they're asking, but what I do know is I can rewrite secant in terms of sine and cosine. So secant is 1 over cosine. And the equation for the sine of 2x is over here, which is 2 sine x cosine x. Put that over 1, multiply through those fractions. I can get rid of a cosine here and here. So secant x times sine of 2x is really just equal to 2 times the sine of x, which is choice number 4. So you see how it's really similar to what we were doing before and just rearranging and rewriting things, but this time they're just giving you new formulas to work with. Okay, the expression 2 sine 30 cosine 30 has the same value as what? This is another one of those let's play the matching game kind of things. Just look on your reference sheet through all of these and be like, which one is the equation that goes 2 sine times cosine? 2 sine of something, cosine of something. Obviously it's this one because it's what we've just been talking about. So 2 sine of 30 times cosine of 30 is equal to the sine of 2a, or in this case the sine of 2 times 30. And what's 2 times 30? That's the same thing as the sine of 60 degrees. So this is choice 3. So 2 times sine of 30 times cosine of 30 is equal to the sine of 60 degrees. Okay? If sine of x is equal to 2/3, find the value of cosine of 2x in simplest fractional form. Okay. I mentioned this briefly before, but I want to say it again. For the double angle of cosine, we have 3 different equations. This one, and this one. This one has cosine squared a and sine squared a. The second option just has cosine squared a. The third option just has sine squared a. Every single one of those equations will give you the exact same answer. However, if you are trying to figure out what cosine of 2x is, you're using one of these equations, and the only piece of information that you've been given is what sine of x is, I would want to use the equation that has sine of x in it. and only sine of x in it. Why on earth would I want to, draw out a triangle, use the Pythagorean theorem, figure out what cosine of x is equal to, just so that I can use the one with cosine or the one with sine and cosine? That doesn't make any sense to me. So what I'm going to do is cosine of 2x is equal to, I'm going to use the equation that only has sine in it, 1 minus 2 times sine squared of x. Okay? So cosine 2x is equal to 1 minus 2 times sine squared x. All we know is what sine of x is. So you're going to write 2/3 squared. And we want our answer in simplest fractional form. You could type this whole thing into your calculator, or you can just do out the work. 1 minus 2 times 2 squared is, 2/3 squared is the same as doing 2 squared, which is 4, and 3 squared, which is 9. 2 times that is going to be 1 minus 8/9. So that's like 9/9 minus 8/9, which is equal to 1/9. Another way that you could have done that was to just put it into your calculator. 1 minus 2 times 2/3 in parentheses squared is equal to that, math enter, is a fraction of 1/9. Same thing. Okay? Not too hard. Use the formula for 1/2 of a, or the half angle, which is right down here, to show that the sine of 45 degrees is equal to radical 2/2. You know what, John? It's been about a month and a half since we've done these kind of things. I don't really even know exactly where they're going with this question, but what I do know is it told me what formula to use. So let's start out there. Sine of 1/2 a. And what is that equation? Sine of 1/2 a is equal to the positive or negative square root of 1 minus cosine of a, all divided by 2. Well, we're trying to show that the sine of 45 degrees is equal to something. So if I want this to be equal to the sine of 45 degrees, I'm going to have to write it as sine of 1/2 of 90 degrees, because 90 divided by 2 is going to give me 45 degrees. Right? So in this case, the a that's in my equation here and the a that's in my equation here, those are going to be 90 degrees. Alright, so let's see what happens. Positive or negative square root of 1 minus the cosine of 90 degrees. Well, what's the cosine of 90 degrees? Let's take a look back. Whoops, wrong shape. Let's take a look back at our unit circle. There and there. 90 is right here. This point is 0, 1. Cosine is the x value that I'm looking at. So the cosine of 90 degrees is equal to 0 over 2. Okie dokie. So this whole thing, sine of 1/2 of 90, or the sine of 45 degrees, that's equal to the square root of 1/2. Now, when I have a square root over the whole thing, it's the same thing as, here, let me write it over here. That's the same thing as saying the square root of 1 divided by the square root of 2. Mathematically speaking, we're allowed to do that. Now, the square root of 1 is really just equal to 1. So this is 1 over the square root of 2. Now, you already know this. We're not ever allowed to leave a radical sign in the denominator. So what I'm going to have to do is what we call rationalize the denominator. And in order to do that, I need to multiply by radical 2 over radical 2. See what that's equal to. 1 times radical 2 gives me radical 2. Radical 2 times radical 2 just gives me positive 2. There it is. That's my answer. So, the sine of 1/2 of 90, or the sine of 45 degrees, is radical 2 over 2. Questions like that aren't that bad just because they told me what formula to use, and they told me, you know, show that the sine of 45 is equal to this. So obviously when I got down here and this as my answer, I knew that I did it correctly. So we always love to see questions like that on the Regents exam. Let's see what else they've got. If the sine of theta is 0.6 and theta is in the second quadrant, find the cosine of half of theta, 1 over 2 theta. Find the cosine of half of theta. Okay, well, they obviously told me that theta was in the second quadrant for some reason, so let me just draw this out really quick. All students take calculus. We're up here in the second quadrant, and all that tells me is that sine is going to be positive, cosine and tangent are going to be negative. Okay, so find cosine of 1/2 of theta. Well, my 1/2 identity is right here on my reference sheet. So let's write it out. Cosine theta divided by 2 is the same thing as 1/2 of theta. So the half angle of theta is equal to 1 plus cosine theta divided by 2. Well, how am I going to do this? Let's think about this. Typically, when we're given some information about sine, it's always in terms of a fraction, right? Because we know that sine is the opposite over the hypotenuse. So if we're given a fraction, we can say, okay, this side is my opposite side, this side is my hypotenuse, and you can figure it out. Well, we were given sine theta in terms of a decimal. So is there any other possible way that we could write or rewrite this information in terms of a fraction instead of a decimal? Well, if I just read that out loud, it's 6/10. So this is the same thing as 6 divided by 10. But you know what? To go even one step further, I can make that smaller. 6 divided by 2 gives me 3. 10 divided by 2 gives me 5. So this is really, sine theta is really equal to 3/5. We know that sine is opposite over hypotenuse. So I want you to draw yourself another beautiful triangle. Pick where your theta is. And sine theta is 3/5, and sine is the opposite over the hypotenuse. We know that this is a 3, 4, 5 triangle, so this side is 4. And now I can easily figure out what cosine theta is equal to. Cosine of theta is adjacent over hypotenuse. So let's plug in that information. Cosine of 1/2 of theta is equal to positive or negative square root of 1 plus cosine of theta is 4/5 divided by 2. Now, so that we don't get this screwed up, because a lot of kids were getting it screwed up, Miss Tompkins made it very clear that in order to do questions like this, she wanted you to put everything underneath the radical sign into the calculator first, and then do the square root.